Good afternoon, everyone. Let's start with our first practical on designing a diode clipper. For that, just open your LT Spice. This is the screen that you get. Go to the file, press New Schematic. You get a screen where you can develop your circuit. You can see a lot of icons which we can use while designing our circuit, which gives us a shortcut to add the components. So as you can see here, this is the wire, this is ground, these are label nets, resistor, capacitor, inductor, diode, and other components. So for making a simple circuit, we need is a resistor. Now to change the direction of a resistor, we can press Ctrl R. Then once you have placed it, press Escape. Click and then press Escape. If we do not click, it does not register it. Then we need a diode. So I just take a diode, click and press Escape. In addition to this, what we need is a voltage source, a ground, and a diode. So we'll go to the components, type here voltage, and press OK. We'll be using two voltage source, one for the input and for defining the clipper. Click and then press Escape. To move any component down, we have this move icon as you can see here. Just click it there, bring it on the item that you want to move, and you can move it anywhere. Click it again and press Escape. Once you have all the components, we need to make a circuit. For that, we'll be using the wire. Click on this pencil icon. You have the wire. Just click from the starting point whenever you want to turn and at the end point. Every time you are making a connection, just click on the starting point and at the end point. It makes a connection between the start and the end. Once you have all the components, again press Escape to remove the wire icon. Now, before we can simulate, we need to give the values to all the components. Just bring your mouse to the component. You see an arrow. Right click. It will open a window where you can give it a value. We'll make it 1K. Press OK. Then this is a diode. We can select a diode from an IC numbers. So for that, pick new diode. I'm selecting IN4148 and press OK. So it gives it characteristics of the SPICE model corresponding to IN4148. Right click on this voltage source, give it a value 2.5. Press OK. Now coming to the input, right click. Now we want the input to be a sinusoidal wave, which we don't see on this screen. For that, click on Advanced. On the left side, you see various types of sources. Click on Sine. You can give the amplitude, say 5, frequency 1K. You can set other values, or by default, it takes it as 0. Press OK. So now you have a sinusoid. Your circuit is complete. Now what we have to do is we have to run it. To simulate it, we can see a icon run for here. Just below hierarchy, you see a man running. Click here. It will ask you what type of analysis we want to do. Transient, AC, DC sweep, noise, DC transfer, DC operating point. We want to see the changes in the output with the changes in the time. Stop time, we take it as 1 milli for 1 cycle. We take the maximum time step as 0.1 milli and press OK. As soon as we run it, it does a transient analysis, gives us a window where we can see the output. As you bring your mouse near your circuit, you see a red probe that will help us to see the voltage at that particular point. You see an arrow, that is whenever we want to measure a current, we have to actually see it inside the circuit. So when we use this icon, it's a current. When we are using this probe, it's a voltage. So let's see what's an input voltage. You see a sinusoidal. This is the terminal where I want to see the output. This is an output terminal. We see from one side, your signal is clipped. Now, if we want it to be clipped from both the sides, we need to add a diode in the opposite direction to clip the negative cycle of the signal. So we just close it, go back to our circuit, and add another diode and a voltage with an opposite polarity. I take a diode because I want to clip the negative circuit. The diode direction has to be changed. I press Ctrl R. And I need a voltage source. So I go to the component, take a voltage source, bring it here, press escape. I take the wire to make the connection. Once our connection are done, press escape, give the IC number to the diode. So basically it's like assigning a spice model to it. Right click, DC voltage, I'll again clip. Now, one thing that we have to see that the diode polarity is changed, and accordingly the voltage source polarity has to be changed. So I just take this voltage source, move it, Ctrl R, and change the polarity and bring it back. Now it will be helpful for us because of the direction of the diode. Now I'll just press escape, again bring my mouse near the voltage and right click and put the voltage 2.5 and press OK. So this completes my new circuit also. Again, I'll run it, but before running it, I'll do two new things. I'll add the label. So can you see the label? Can you see the label icon next to the ground? Just click it. We want a label at the input to define what will be the location for the input terminal. And port type I selected as input. I bring it and keep it here. Now again, I go to the label. I want at the output also. I type the name, select the port type as output, press OK and bring it here. Now I take the wires and make the connections. And now press escape. Whenever your circuit moves out of the screen, you can just go to this zoom full extent. So it brings the content back to your screen. Now we have to add the title. So for that, I take this text icon and type Clipper and press OK. So it gives me the title. I just place it and my circuit is complete. I'm not changing anything in the way I want to run it. So I maintain this statement. In case I want to remove it, I have this cut. I can just come and remove it and press escape. So I again go to this run. It will ask me the stop time, the step time, the other values default are 0. Press OK. So now I know where to take my input. I just put my probe there and output. So this you can clearly see the signal is clipped in the positive as well as in the negative side. So this is your clipper circuit. Thank you.